Good morning or good evening. It depends where you are based in this moment. Welcome to the Pavement Bearing Capacity Evaluation webinar arranged from Dynatest. So today we provide a small introduction about the principle, measurements, and evaluation of the bearing capacity. So, small presentation about myself. I'm Umberto Pinori. I'm senior pavement engineer at Dynatest. I'm based in Italy. I have more than 15 years experience in pavement survey and evaluation. I'm responsible for the equipment and software application. I support the R&D activity and lead the consulting unit. Here you can find my reference and my contacts. So please feel free to contact me for any question. Just a small info about the webinar. The webinar will be recorded and the link distributed at the end of the session, and it will be available also on the Dynatest channel on YouTube. Camera is always off for all the attenders. The attenders can sign as anonymous if you want. You can hide your name. The attenders can switch on the subtitle from the option panel of Teams software. And for question, please wait the end of the at the end of the webinar. There will be a session of Q&A, but you have to write your question in the chat panel. You can write the question also during the webinar, and we'll take care to answer at the end. An outlook about the today webinar. We introduce the concepts of the bearing capacity. We have a presentation of the equipment for the bearing capacity measurements. An historical view of what are using on the road and what is current using. What is the pavement evaluation? So how we can evaluate the pavement performance and forecast the residual life. And how the Dynatest ELMOD software can support you in this process. Introduction. What is the pavement bearing capacity? So this is very important. The load bearing capacity indicates the capacity to support traffic loads. If the load bearing capacity declines, pavement becomes unable to support the traffic load and deflect under the load. This deflection, it depends on the entity, results could generate damage on the surface and inside the pavement. So if you see the picture on the left, you see a very black new pavement. And probably most of the people, when think about a road, they have in mind this type of picture. But in reality, the pavement during the life, they are going to change their status. They receive damage. So there is a decreasing of performance that is reflected in distresses or defect on the surface. It depends on type of defect and the entity. Of course, the road can reach a non-operative condition. So you see on the right, more or less the same road, but in bad condition because it's affected by deep rutting and probably oil spillage and other type of defects. So we want to measure the pavement bearing capacity of the pavement to estimate if that pavement can support the load, the expected load or the forecasted load traffic for the entire design life. It's very important to define how we can model the pavement. So how we can represent the pavement. The pavement is a sequence of layers, each of one characterized by a specific design in order to satisfy specific target. And usually we isolate the subgrade, that is the semi-infinite space. And then we have a subbase layer that usually is, or foundation layer, is a granular material. The grain size can be controlled or not. Countries are crushed stone. In some other countries, they use recycled aggregates. So the nature of each aggregate can be different, but at the end, the scope is more or less the same. Then we have a base course. It depends on the traffic level of the road and subgrade condition. The base can be bonded or unbonded. Lean concrete or asphalt foam bitumen, emulsion stabilized, and other type of bonded material, or could be again another type of crushed stone unbound material. On top, 99% of the time for flexible pavement, we have an asphalt binder course and the welding course. Of course, usually each layer is characterized by different thickness, and thickness is very important for the pavement model. So what we define the subgrade is very important that we have in mind what is the subgrade. Because sometimes during the training we perform for the ELMOD software, also the definition of the subgrade is the same. So usually subgrade is the part of soil placed around 40-80 centimeters from top of the pavement. And this is assumed as semi-infinite. If you have an embankment, the subgrade is not the soil where the embankment is placed above. No, it's placed over. No, the subgrade is defined as the layer where the foundation is placed on. So it's very important. The subgrade, of course, is always assumed as pure elastic, semi-infinite, but the subgrade nature can determine viscoelastic and plastic deformation under traffic load, because very often this natural soil is not pure elastic material. And the subgrade characteristics determines all pavement structure above. So if more is weaker is the subgrade, and more strength you need inside the pavement in order to support the traffic load. The subgrade strength very often depends on the grain size distribution, in particular the 75 micron passing, the porosity, and the water content. What is the foundation? The foundation is the material placed between the subgrade and the asphalt concrete in a flexible pavement material. Pavement, in a flexible pavement. And the foundation layer is the separation between asphalt and subgrade. And the main target for this specific layer is distribute the stress induced by the load. So create a separation that provide enough thickness to distribute the stress in order to reach a level on top of the subgrade that can be enough reduced to be supported by the subgrade. On top of flexible pavement, we have asphalt concrete layers that usually is not only one layer, but there is a sequence of asphalt layers. And these are fundamental to absorb and distribute the traffic load. And in particular, the surface layer is very important because is the layer placed in contact with the tire. So the surface layer has to guarantee particular requirements that not always are linked to the strength and to the bearing capacity, but are more linked to the functional characteristic of the road. So the surface layer is very important, constitute the top of the pavement, and should be able to withstand high traffic and environmentally induced stress without exhibiting unsatisfactory cracking and rutting. But very often this cracking and rutting appears on top are not due only to the surface layer, but are due to the whole entire pavement. And depends also on the local condition that are very important. And local condition is temperature condition, weather condition, and the weather condition, of course, affect also the subgrade. And the surface layers, of course, has to guarantee the macrotexture enough to have a good skid resistance, a noise reduction, and durability of the wearing course. In some cases, the rapid drainage of surface water is desired, while in other cases, the wearing course should be impermeable in order to keep water out of the pavement structure. So it's very important that the surface layer remain in good condition for all the entire life. And this depends also on the support of the below layers. Pavement modeling, which is the model we use in pavement evaluation. Usually is a multi-layer linear elastic material, and each layer is characterized by three main parameters. The first one is the thickness. The second one is the Poisson ratio. And the third one is the elastic moduli. So when we know these three parameters, we are able to characterize the performance of each material inside the pavement. The pavement model allows a mechanistic approach for the pavement evaluation. And this is very useful during the design phase because we can simulate the traffic loads, so we can induce in the pavement exactly the real traffic the pavement will receive during the life. We can characterize the material properties of each layer, and we can calculate stress and strain. So in each point of the pavement, using different method, we are able to calculate stress and strain. And of course, we can assume some material performance, like fatigue load or decreasing load, that come from experience or experimental side. The other method is the empirical method, are based only on test section and experience of observation. So they are less scientific. And of course, the number of information the empirical method can provide is considerably reduced compared to the mechanistic approach. Pavement measurements. So what we measure and which equipment we can use. So in the pavement sector, the most used bearing capacity measurements are based on empirical method. So traditionally, we use the CBR to measure the bearing capacity of the natural soil in lab and the loading plate test on site. But these two types of tests are really limited for the pavement evaluation during the in-service life of the pavement. So we have the CBR. The CBR is the most of you will know that the CBR, of course, is a specimen prepared in the lab and test with this particular machine that measures the penetration inside the soil. So we have some positive points of this type of test because it's fast, it's easy to conduct in any condition. So any lab can prepare this type of test. And of course, there is a long tradition in result evaluation. So if I say a soil is characterized by 10% CBR, most of us know that is a good material. So the soil is in good condition and can support very well the stress. What is not positive is this is based on an empirical method. The test limit to the soil and granular material. So we cannot test and we cannot get similar results for asphalt concrete. And of course, not reflect the real performance condition, because the test conditions are totally different from the load applied on site. The second one is the plate loading test. Again, this type of test, of course, is carried out on site and simulate a little bit better what happened in the real life. The positive points is that the test is quite fast, not too fast, but of course it's very good because measure the material condition on site. So we measure the material in the same condition of the real traffic application. And of course, there is a long tradition in result evaluation. This type of test, of course, has a considerably amount of not positive points. Again, it's based on empirical method. The test limit to the soil and granular material. It's not reflect the real material performance condition, because of course the load of the in this test is applied for a long time, and the test waits for the assessment below the plate, so it can take a long time. But the real load applied by the traffic is impulsive. It's very fast, so the pavement has no time to have a settlement, but there is a deflection. So the physical approach to the phenomena is different. The PLT requires support of EV vehicle has contrast, and of course it cannot apply directly for existing pavements, but in case they need to create a pit where place the PLT. So by the time, different methods have been developed for the full pavement bearing capacity evaluation that try to replicate the real in situ loading condition with not destructive tests. And this, most of these tests are Binkelman beam, deflectograph Lacroix, and then the falling weight. What is the Binkelman beam? Is a beam placed in the middle of dual axle load of truck, and the beam measured the deflection of the pavement. Then the truck move away, and the system recorded the deflection of the pavement without the load. The difference provide some information about the residual deformation. So the positive point is simulate the real traffic load condition, because of course the load is a real truck. The test measures the real pavement deflection. Of course, the moduli, the elastic moduli calculated is static, because the load is applied in a static way and this is not elastic. But there are some correlation with the deformation module, CBR, and the elastic moduli get from the falling weight. Not positive points are the test is very slow, is sensitive because it's very variable, the measure. They need to totally close the lane. There is operators on the road, so of course there are some safety issues, and requires support of EV vehicle for load application. So here you can see a test, a video where this test is conducted. In this case, the beam touch the pavement exactly in the middle of the dual axle load. And now we see the measurements of the deflection recorded. And now the truck is moving away and the deflection is going to decrease. So the difference provide the residual deformation of the pavement assumes for the moduli calculation. An evolution of the Binkelman beam is the deflectograph Lacroix, where there is a mobile beam that is moved below the track So, and place down, and the truck in the while the truck move on and go closer to the beam, and then again the beam is placed 1 meter over, and so there is a continuous repetition of beam place and measurements. The positive points, of course, is the simulation of the real traffic load condition. The real pavement deflection. The deflection is measured at different distance from the load application point, and in that case there is a dynamic load and there is no operator on the road. What is not positive is the test is low, is approximately 5 km/h, is an old technology, and again require the support of EV vehicle for load application. Here you can see a video that show the principle, the work of the machine, and there is the beam that is moved and waits for the load. So in the meanwhile, the system can record different deflection at different distance of the load from the beam. The evolution of all these two systems are concentrated in the Falling Weight Deflectometer. The Falling Weight Deflectometer is a system characterized by a load plate and 9 geophones that are placed at the same moment on the pavement during a load application. So the positive point is a higher number of load repetition. We can set different type of load levels, easy run in any pavement type. We can set different number of geophones to record the deflection. There is no operator outside the towing vehicle. The information collected are used for backcalculation in order to calculate single layer elastic moduli. The nonlinearity in material behavior can take into account during the elastic moduli calculation. And of course, the information are useful for the residual life estimation. The negative, if it's negative, the frequency cannot be changed. So the load frequency simulate vehicle at around 60 km/h. So it's very important because backcalculation allow to estimate the elastic moduli of each single layer and not the entire overall pavement. So most of the previous measurements can provide information only on overall pavement and not layer by layer. This is a video about the falling weight during test. So the loading plate is placed down and the geophones that are here. One mass is raised. The number of masses can be changed, and also the height of drop can be changed. So in the moment where the drop, where the mass is released, the deflection is recorded. Usually it takes around 1 minute to arrive in one station place, run 3 drops, raise the plate and the geophones, and move away. During the time, different versions of the falling weight have been developed. The original one is the falling weight you can see in this picture. And in this case, the masses are raised using hydraulic system. Since around now is more than 5 years, Dynatest produced the fast falling weight, where the masses are raised by electronic spindle engine, and it's very fast. And there is the last version is the heavy falling weight deflectometer, where the double of masses have been introduced in order to simulate the stress induced by the aircraft. Just to show you what we mean about fast, this is the speed of drops of a fast falling weight. If you see, they are very fast and they cut out around 50% of the time during test. In addition, the number of drops we can reach for each single station without moving the equipment is around 2,000 per hour. And this is very useful in case someone wants to use this equipment for to simulate the APT test. So the falling weight, what it used for? The first point, of course, is structural capacity evaluation and remaining life estimation. But for rigid pavement is very important because we can verify and measure the load transfer efficiency and the void detection under the concrete slab. At network level, the falling weight investigation can be used to implement a pavement management system. And at project level, the information can be used for the evaluation and design phase. In addition, the falling weight test can be used for quality control and quality assurance and many other research applications. Which is the falling weight principle? The first one, the equipment arrive at test location. They lower loading plate on the pavement with the geophones. Then the weight is raised and fall on the loading plate. Here there is a load cell that recorded the stress applied, and then all the geophones register the deflection. And then after 3 drops, the load plate is raised and the falling weight can be moved to the next station. And the test takes around 1 minute. So here you can see a video of the falling weight acquisition software. So in this case, 6 drops are applied for each station. And you see that here you can visualize here there's the chainage, the station, the stress applied in terms of pressure and force, and the deflection recorded from any geophones placed to the pavement. Additional information are recorded at the same time, like air and surface temperature, and GPS. And 1 camera or 2 cameras can be placed for surrounding area picture or for pavement picture collection. The falling weight simulates a dynamic load transmitted to the pavement surface by wheel of any weight vehicle at a speed of 50-80 km per hour. This is very important because we can replicate the real stress and strain induced in the pavement by the traffic load. Dynatest developed the falling weight equipment, but also the ELMOD software for backcalculation. Backcalculation is a very important process that allows to calculate the elastic moduli of each layer in the pavement. So the input data are load, deflection, and layer thickness. In this way, we are able to calculate the through the backcalculation the elastic moduli. Adding additional information like temperature, seasonal effect parameters, we are able to calculate elastic moduli for each season. Any kind of material that is dependent from the temperature or from the season can be simulated, in this case, asphalt, concrete, or subgrade. And again, in this case, we have the design models for each layer and season. Applying the design load, we can calculate stress and strain for each layer. If we know which is the performance criteria or the deterioration model, we are able to calculate the residual life. And based on the residual life, specifying the design period and the design material, we are able to calculate the required overlay. In this case, we have a point-by-point design. Which are the principles of the back calculation? So in this case here, we can see the basin recorded during collection. So we call it measure. We have a plate radius 150 millimeter. We apply a load with a pressure of 1700 kilopascal, and we measure this this basin here, where the D1 is 600, and we have all the rest of the deflection values. So as trial one, we enter seed moduli value, because the system has to know number of layer, thickness, and some seed value of the moduli. So for example, we assign to the first layer 3000 megapascal, the second layer 450, and at the third layer 150. The software create a multi-layer system, apply the same load we have specified here, and the software calculates the deflection for this type of pavement. And if you see here, we have as results the orange basin that is not overlapped the blue one. It means that the software has to improve the quality of the moduli in order to get a basin that is more closer to the measured one. So at trial 2, at the second step, the software increase the value of the elastic moduli of each 3 layer and calculate again the deflection. And if you see here, now is more precise, because we have the green. As at trial 2, we get the green basin that is closer to the blue one, but is not enough. So the software try to optimize again, and at trial 3, the seed value are 3,800, 650, and 200, and the calculated deflection is the yellow one. And if you see now at trial number 3, the values obtained from the elaboration are pretty closer to the measured one. This means that the elastic moduli assumed for the calculation can correspond to the combination of the elastic moduli in place of in the material measured. Of course, the number of iterations provided by the software is much, much higher, and now we will see. So the first one in the ELMOD backcalculation software process is the step 1 is define the structure. So it means that you can use, like, for example, GPR, and for any station, the thickness of each layer is defined. So if you see here, the thickness change point by point. And here you have a graphic representation of the thickness that is variable. Or you can assume, for example, design value, and you have a constant thickness for a certain amount of points. And here you see that now we have this seed value here of this for these 3 layers. And if you see, the red one is the measured deflection, as an example before, and the green one is the calculated deflection. So if you see, these are the seed value, but they are quite distant, so the operator has to adjust it manually for the first attempt. So now we are going to change the value. If you see here, they adjusted the AC, adjusted the foundation. And if you see now, the green one overlapped a little bit the red one. So these values are good to start the elaboration. And now the analysis will be run. And you will see that the software run a lot of iteration. If you see here how many times change the calculated value in order to minimize the error between calculated and measured value. So this is the example how the backcalculation works. At the end of this process that is provided by the software, what we have the elastic moduli calculated. So the blue one is the E1, the green one is the E2, and the red one is the subgrade elastic moduli. it's important that you know that the asphalt concrete elastic moduli is temperature dependent. So the first result is the elastic moduli is provided at test temperature, but through the material properties that is specified in a parameter setup, we can adjust the AC moduli at the reference pavement temperature. And in this case, you see that now the blue line is much higher. Here, for example, is around 2,000, and here is around 4,000 or 5,000. In this case, of course, we transfer from one case to the other one. And similar adjustment can be provided for any kind of materials according to what we specify in the parameter setup. In addition, if we know which is the real traffic condition, so if we know the amount of for example, amount of vehicles for each typical class of vehicle, and for each class of vehicle, we know which is the weight of the axle, we can simulate the traffic, the real load applied to the pavement. And based on fatigue criteria or decreasing model, we can calculate the residual life. So if you see in this graph here, the green line is the life, the residual life. If you see in this table, we have the first station has a life of 10 years. The second station has a life of 3 years, and all the rest that we can see in the table is 40 years. If the residual life in terms of years is below the design life, the software provides you an overlay calculation in order to determine which is the minimum overlay thickness that has to put on the existing pavement to satisfy the design life. So in this case, where there is a life of 10 years, the pavement needs 3 centimeters, 31 millimeter of overlay to guarantee 20 years residual life according to the performance criteria assigned to each material in the parameter setup. The second station, the residual life is 3 years, and the software calculates that 150 millimeter is needed to guarantee 20 years of residual life. And in the other points, since the life is over 20 years, the overlay needed is 0. In the rest of the graph, there are other. So in this case, we provide an evaluation of the bearing capacity, because we can get which is the residual life. And the residual life is the minimum life of all the layers considering the pavement. So for each layer is applied a performance criteria or fatigue law, and the minimum of life of each layer is the minimum life of the entire pavement. So this is the workflow of the ELMOD software. Then, of course, there is the export of the results. The most useful one, the fast interpretation of the results, of course, is reported on Google Earth or any kind of georeferenced data. So here we have an airport case or a road case. Color is good because you can immediately recognize or detect the critical area and good area. Additional information and elaboration that can be performed with the falling weight. Important is for the rigid pavement. With the rigid pavement, we can evaluate the performance of the load transfer at the joint. So placing the equipment in the right position where the two deflections are across of the joint. We can evaluate the load transfer efficiency that is very important for the rigid pavement. And so we can evaluate the quality of the edge status for each slab. In addition, we can calculate a ratio between the K value calculated in the subgrade at the joint of the slab and the K value calculated in the subgrade in the center of the slab. This is another parameter that is very useful for the rigid pavement. And again, for the airport case, if we know the traffic spectrum in terms of aircrafts, we can calculate ACN, PCN parameters. So that is a typical value for pavement evaluation in airport. Automatically is calculated the PCN and the critical aircraft for each station, and is generated also the ACN value and the code for the PCN. And it's very important because PCN is calculated for each single station. So the real payment model of each single station is assumed for ACN PCN calculation. We have not provided an average of all elastic moduli we have in one single alignment, but each point is calculated in the real condition as the payment layers are. And this is very important. So this is another good example how the falling weight can be used for payment evaluation. And so we arrive at the summary. In this short webinar, we have seen what is a payment model. That is very important that you have in mind which is the model of your payment. So if you want to simulate different layers, because each layer is characterized by the material that has a different performance criteria from the other. Then there is a bearing capacity measurements, so which are the typical equipment used for bearing capacity evaluation. What is the backcalculation and why it's so important in the payment evaluation process? Because backcalculation is probably the only one method that allow you to recreate a model of the existing payment without destroy the payment. And since the falling weight is very fast in the test, so the number of test points per hour, you have a very detailed picture of bearing capacity across your entire pavement network. And this is good because if we are able to recreate a model of the pavement, we are able to estimate a residual life. That is a fundamental parameter for the pavement evaluation. So we can estimate if the pavement will have or not problem from a structural point of view. So it's very important remember that we have pavement evaluation usually is associated to the structural parameters and functional parameters. In that case, we concentrated on the structural point of view. So thanks to attend this this webinar, and now that of course we are trying to run a multiple webinar. It's very short, so we don't want to go deep in details. We will arrange more webinar for specific topic. So this was just a main introduction to the bearing capacity. So please feel free to add question in the chat so we can discuss about your question. A question is any guidance to determine good seed moduli? We had the same question this morning, so probably it is a very important point. Of course, there are some papers that provide a certain amount of acceptable interval for each type of material. So you can start to use that type of interval. Of course, for example, asphalt concrete change a lot based on the asphalt temperature. For example, I'm based in Italy, and here the asphalt concrete temperature can be 40 degrees in the summertime during the day, and could be 0 degree in the winter time. So of course, the seed moduli, it's very variable according to the test condition, because the same asphalt concrete can have can be represented by 2000 megapascal in summertime and 10,000 in the winter time. And of course, it's still the same material. So anyway, you need to look for seed moduli manually in order to adjust the starting point of the first basin. The second question is, are there any technical background for the fatigue equation in ELMOD? Yes, there is a list of fatigue equation already included in ELMOD for any kind of material. So asphalt concrete and subgrade mainly, but also for concrete slab. So you can use that one. There are, I don't know, more than 10s for asphalt concrete. Some of the fatigue criteria are based on stress, some are based on strain. And when you go in the material setup, you can select and plot on a graph all this kind of fatigue equation. So you can decide which is more conservative and which are less conservative, and decide which one you want to use for your elaboration. If there are no other questions, we can stop here. How can you create new materials? You can create. Yes, of course, from lab test. Yes, the fatigue. There are two ways to generate fatigue equation. So, and evaluate the material performance criteria. One is from the lab test. It could be for the soil triaxial test, and for the asphalt concrete, you can use ITS test or 4-beam point test. Or from the site, you need to run some accelerated pavement test. So you are, if you are able to apply a certain amount of same amount of load repetition you have on site during the lifetime, you can, of course, evaluate the performance behavior. And in that case, you can generate new fatigue equation. Bagus request, I see ELMOD has several backcalculation methods. FEM, LET, MET, which one is the best? FEM is the finite element method. LET is the linear equivalent, linear elastic theory, and MET is the method of equivalent thickness. Each of them, of course, has a positive points and less positive aspect. It depends how much this each theory can represent the real behavior of the pavement. Usually, method of equivalent thickness is the most used one. FEM is very good, but it takes a lot of times in the elaboration. So of course there is a technology limitation at the moment in using FEM. MET is much faster. Another question is, could you please address the minimum thickness of asphalt concrete for back calculation analysis and a seed model should be used? The theory say that the minimum thickness is equal to the half of the plate radius, the loading plate radius. So in our case, we use 150 millimeter. So this means that the minimum asphalt concrete thickness is 7.5 centimeter. So this is so something between 8 and 10 centimeter is the minimum thickness you can use for a good back calculation results. Of course, the back calculation is provided also with thinner layer, but the results is not so good. We internally in Dynatest at the moment we have some research to evaluate how to eliminate this problem evaluate if the back calculation can be used also for thinner layer. But some research are going on. And how can you find CBR of the layers? The CBR of the layers using the falling weight, you mean? There are some correlation that allow to transfer the elastic moduli value in the CBR. Usually the most used one is that the elastic moduli is equal to 10 CBR when is expressed in megapascal. So this is the most used one relation to convert the elastic moduli to the CBR and the CBR to the elastic moduli of the material. Thanks to attend the webinar. You will receive a presentation and link to the video shortly by email. And I hope to see you to the next webinar presented by Dynatest. Thanks all. Bye.